Hello, everybody. Today we're going to talk about the second step of the engineering design process, which is to research the problem. In this step, we identify existing solutions, possible problems we may encounter, and develop questions that need to be answered to develop a successful solution for the design challenge. So, as we start to go further into this, at this point, after we identify and clarify the problem, which was step one, in the second step, now we're going to start to research the problem. We're going to start to look into possible ways to make it and things we need to know. One of the things we have to identify are constraints. Now, this is one of the words definitions you have to type onto the worksheet that goes with this lesson. And the lesson for constraints is limitations imposed on problems such as available resources, laws of nature, people's values, etc. So constraints are things that limit our problem or solution in some way. Some other examples would be project budget, types of materials available to work with, available technology, or the laws of physics and things like that. These are all ideas, and there are a lot more that could possibly constrain and keep us from coming up with a solution or things we have to work around. For instance, if we go to an architect and we ask them to design a house and we give them the budget for that house, how much we're able to spend and pay for, and they come back with a 50-room mansion design, well, it might be a really cool house design, but if we can't afford that, it does us no good. Sometimes the types of material available also can limit a project. And a good example of this was the X-33. This was NASA's experimental space plane that they were working on designing to replace the space shuttle. And they actually worked quite a bit to come up with the design. They've started to build prototypes that they are going to work with and possibly launch into space. And one of the constraints for the project was to have this be a single stage to space rocket, which is actually more of a space plane. It was going to take off like a regular airplane would uh, and fly up using a new design rocket engine, which, geez, I can't think of the name. It was some sort of wedge design, much different than normal rocket engines. Fly into space using that, and then turn around and fly back. And the engine design actually came from the 60s. And in the 60s, they couldn't build that engine when they were designing the Apollo rocket because they didn't have materials which would withstand the heat and pressure. Well, when they got into the 80s, they now had materials that could withstand that heat and pressure. But the problem they couldn't solve was the fuel tank for the X-33. Every time they tried to put enough fuel in it for it to reach orbit, the fuel tank would crack. And they couldn't put another fuel tank, external fuel tank on because that wouldn't meet the design constraint and the cost budget that they were working with. So they had to end the whole project. So that would be available material problem. They just didn't have material that was strong enough to pressurize the fuel tank. Sometimes it's available technology. Do we even have a technology that would work to solve that problem? Or simple things like laws of physics. How do we work with those in our constraints to make sure that our project works when it gets done? Now, we're going to be working on a bridge project eventually. It's going to come up within the next few days. One of the things that we need to talk about with our bridge projects, one of the constraints we have, is force. And force is designed as something that can change the state of an object. So, with that, make sure you put this definition on the worksheet as well. But when we start talking about forces, sometimes forces are very apparent to us, like the space shuttle taking off in the one picture. It's very apparent that those rocket engines produce a tremendous amount of force to lift that gigantic heavy spaceship up into outer space. Or when we hit a ball with a baseball bat, we can feel the force in the bat as that ball changes direction. All right. So we're changing the state of that baseball. It's coming in one direction and we're sending it in a different direction. If you ever saw a car accident, you realize the force that's put on the car by the damage that's done. You can see the metal that bends. And if you ever tried to push on metal or something, you see how strong it is. It doesn't bend easily. So we know there's a lot of force at work there. But when we go to look at a bridge, we don't see the force at work. And we're lucky we don't, because if we did, that might be pretty bad for the bridge. We see a trolley going across the picture in the bridge, and we know that trolley must weigh thousands and thousands of pounds, but we don't see the force that it's putting down on that bridge as it goes over. So when we start talking about bridges, we are going to be putting force on that bridge to see how much weight it can withstand. We don't want to see that force at work. We want to make sure our bridge is strong and stays up and stays together as we put force on it. Now we're going to go over some types of forces that will be acting on our bridge. The first is going to be tension. Tension is a force that pulls apart in two different directions, like the arrows. Tension is the way a bicycle lever works with the back brake. When we squeeze on that lever, it pulls on that cable, and that cable is going to pull those back brakes closed, which back brakes would be another force we're going to talk about. But when that happens, that cable is under the force of tension. It's being pulled apart in opposite directions. Another one, when someone walks on a tightrope, the weight's in the center of the tightrope. That tightrope is pulling in opposite directions. That is the force of tension at work. The person in the center tensions that rope. A suspension bridge, like the Golden Gate Bridge, works because of the force of tension. Compression is the second force we're going to talk about. Compression is a force that pushes together. When we look at compression, we can see this board broke because there was a heavy force of compression that was put on top of it. When there's too much weight put on that board, the wood fibers can no longer hold it, and it causes it to break. That's because of compression. A ballpoint pen, a click pen, works because of the spring inside. Springs work because of the force of compression. We put a load on that spring and it wants to push back. We're compressing the spring. An arch bridge works because of the force of compression. And balloons compress the air inside, and that's what gives them their shape. Our teeth work because of the force of compression as well. As we bite into food, the food is compressed and breaks apart. That's another force that's going to work on our bridge, and that one's pretty obvious. If a car drives over a bridge, that car will be compressing on that bridge. The last one is torque. Torque is a twisting force. When we talk about torque, a lot of times when we put weight on a bridge, it's going to respond by twisting as the weight increases. Another tool that works because of torque is a wrench or a screwdriver. Those work because of the force of torque. And when you see that Corvette smoking its tires, those tires are burning off because of the force of torque, that force that those wheels spin with. So those are different forces that are going to act on our bridges. Make sure you copy those down onto the worksheet, and to finish the worksheet, give an example and explain how you've used one of the forces in your everyday life. Make sure to turn the worksheet in when you're complete. Have a great day. See you on the next video.